My name is Marco. I come from Italy. You may have seen this nickname if you are on GitHub. That's me. I'm part of the Doctrine team. Who here knows about Doctrine? Okay, so everyone knows about Doctrine, so we can skip. You can directly go and have lunch. Just kidding. I'm a Zend framework contributor, and you can find me on Twitter and on GitHub as Ocramius. I work on a set of projects right now. They're all oriented on Zend Framework 2 and Doctrine. And why? I'm having fun. The real reason is that I do it for Saturn. I work for Saturn by night. Okay, Zend Framework 2 and Doctrine 2. I'm not going to cover much of Zend Framework 2 today, but more like Doctrine 2. I actually thought about building initially just a base presentation, but since there's a lot of people here who know about the ORM, I'll just try to skip over. Doctrine project is basically a set of projects that are oriented to persistence. So basically, we handle everything that has to do with saving objects. In Redis, in CouchDB, in MySQL, you don't care. We do that. We work on that. The ORM specifically is an object relational mapper, so it takes your objects, maps them to a database, and saves them. It's built on the JPA of the Hibernate and Java, generally, the Java world. So that's where we took our inspiration to start working on it. And it is based on a database abstraction layer. How many of you have used the database abstraction layer directly? So 1, 2 guys, okay. So basically what happens here is that we throw away all the differences between all the persistence layers, and we basically have a common language for all the SQL databases. And you can basically take any object, explain the ORM, here's how the object is built, please save it for me. So controllers, sessions, you name it. And the idea is that you work with an in-memory graph of objects that you basically use and move around and connect with each other, and you don't worry about the database. And you just get everything saved for you. You don't worry about that. So simply put, you just forget the database. It's not your problem anymore. Doctrine works with plain old PHP objects, POPO, that's how they're called. It's funny, but that's how they're called in PHP. And specifically, when we have an object with an identifier, which is basically an ID, then we can call this object an entity. I'll just go directly to demonstrating a simple setup. So I'm trying to install Doctrine on Zend Framework 2, on a Zend Framework 2 setup. To do that, we have a set of modules. So modules in Zend Framework are basically small libraries that you plug in, and they provide some functionality. So they add functionality to your stack of your application. And we have 3 modules at the moment. There's DoctrineModule, which basically takes all of Doctrine project, all the common interfaces of Doctrine projects, and adapts it to Zend Framework projects. We have an ORM module, which is specific about the ORM. It basically configures the connection for you to the database, and that's basically it. And a MongoDB ODM module. So if you use MongoDB, you can basically throw the stuff in, and it works. I hope so at last. This is how it looks like. So what you see, I know these graphs are hard to read. I get always bad reviews for the presentations because I write these graphs and they're hard to read, and someone I must fix it. Anyway, you have at the top this Doctrine common package, which is a small set of interfaces that are common to all of the Doctrine projects. Then you have the ORM and the ODM at the left and the right, And then the green ones are the modules that adapt the interfaces of Doctrine and make them usable in the Zend Framework 2 project. So what we do is basically taking features that usually were built for ZendDB, which is a component of Zend Framework, and adapt them to Doctrine. To install it, I suggest using Composer. Actually, no other installation method is supported anymore because it's just too much work. What we do is basically cloning the repository for Zend Framework. For this skeleton application, I clone it in a directory which I call demo. I cd to that directory, and then I run the Composer installation. And what I'm saying Composer here is grab me the ORM module and grab me a developer toolbar, which is another component. It's useful for debugging. So I always suggest using that. Then I cd to public and I start localhost. So what I did is I actually already cloned here all the stuff because we can't do that in the Wi-Fi of the conference. So I go to the demo, I go to the public directory, and I can start the server. So that starts a PHP embedded server. So how many people have used that thing for developing? Anyone ever used this? That's quite nice. I don't need Apache. I don't need to set up anything. I can work with PHP. I can download the zip from php.net if you're using Windows, which you shouldn't. I'm using Windows. I shouldn't. Anyway, and this is it. I don't need to set up an Apache server, virtual hosts. I just have to browse to the directory, and then I can just go to localhost 8000. This will take a bit. This computer is quite old. But basically that's it. And now I have my Hello World page for Zend Framework 2. And that's it. So I actually picked the wrong presentation. Yeah, that's it. Okay, that takes a lot of time. As said, you have to download a lot of components, which are handled by Composer itself. And then we have to enable the modules. So what we do is we pick the Zend developer tools, the Doctrine ORM module and the Doctrine module, and enable them. I go directly and do that. I have the file directly open here, and I already wrote the lines. I just commented them. Okay, so far so good. Nothing should change in our application. It should look like the same anyway. And there's just another thing that I have to do. I'm really sorry for that one. So demo, config, add to load. I have to rename a file, that's it. So if I now refresh my page, I should basically get the toolbar. If you see this, this is a development toolbar that I got. And these two icons on the right are for Doctrine. So what I get is directly an overview of what is going on, what is happening under the hood, what is the ORM or the ODM doing. In this case, I'm having the ORM, so it is logging all the SQL queries, and it is checking what entities I have in my project. So let's go back a bit and see more basic stuff for a moment. I have to set up a couple of things then. So basically, the ORM works with a concept which is called mappings. So I have these base objects, which are the popo, and then I have mappings. And these mappings basically explain to the ORM how our objects look like, how our objects should be saved and loaded from the database. And this happens through mappings. What I'm telling here, and many people joke about Zend Framework 2 being a framework that builds applications from big arrays, is basically I'm telling, okay, my entities are in the directory SLC application entity, and you should use annotations to load mappings from them. And then I'm telling, okay, for every entity that is in the namespace application entity, please use this configuration. And of course, I have to set up the connection to my database. So I'm just telling, in this case, I'm connecting to localhost with username, password, and database names. And then I'm saying what driver I'm going to use. So in this case, I'm using PDO MySQL. You can use Oracle. You can use EBM 2. You can use Postgres, SQLite, whatever. And then let's get to concrete stuff. So I'm writing a first entity. An entity in the ORM is just a simple class. In this case, I'm putting annotations in it. But basically, the concept is that it's an object that you write, and it comes with these mappings. So this is a user class, and I am basically saying, okay, ORM, this is an entity. And then ORM, this field ID is an identifier. It is auto-generated. It is an integer. And it has and this entity has also a property name, which I tell the ORM this is a string, so save it on the database as a string. And then I have getters and setters, which I didn't write here in this slide. Okay, everything okay so far. Let's go on and just apply the changes that I wrote. I'm going to pick basically the code from the presentation and put it in the locations where it is supposed to live. So what happens is that the ORM is now able to read my entities. So let's check if this runs or if it explodes, because I may have a typo. I mean, doesn't mean. Is it exploding? Is it doing anything at all? Hello? Yeah, it's doing anything. So, okay, ORM validate schema. This basically tells us, okay, check if anything is going wrong. And so far, the ORM is saying, okay, the mapping files are correct. Okay, the database is in sync. So we don't have any entities for now. I'm just going on and renaming a file, which I already wrote. So this is the entity file. That's exactly what we had in the slide. I just added the getters and setters after that. And if I now run again this command, the ORM says, okay, the mappings are right, but wait, your database is not in sync with your schema. So the idea is the ORM takes control over your database. You don't worry about writing a database anymore. It's not your problem. You don't deal, do you actually work with your users and work with user tables, or actually do you work with user objects and say user register, or take the email service and send an email to this user? Or do you actually take an emailer and say, here's a table? I mean, that's the concept. You move away from databases and move to having this basically usage of the ORM, which enables you to use these objects, which are much more near to your business logic. So what I'm telling then is, I'm just telling the ORM to generate the database for me. So there's a command for that. I'm just running again this command in command line ORM schema tool create. And this command will create the database for me. So I now do have all the tables that are needed to work with it. Is this okay so far, or does it look like black magic? Okay, it's not really for everyone, but it simplifies a lot of things on the long run. Okay, let's try this out. How does this work? I'm going to write this piece of code in an index controller. So we have this MVC set up, and somewhere we have a controller, already exists. I'm just going to drop this code in it. So what we do is we take the object manager. Object manager is like the initial point where you start working. I call it object manager because that's what it does. It loads and saves objects. I take the service locator, which is basically a container with all services that you may need. And from it, I take this entity manager, which is the ORM specific entity manager. And then what I do is I build a user object and set a name, in this case, Zaphod Bibelbrox. I don't know if anybody watched it or read the Hitchhiker's Guide to the Galaxy. Anyone? Nobody? Seriously? Okay, 2 people. Shame on you. And then I say, okay, object manager, persist this object. Persist this object, which basically means, okay, take this object and start tracking it. And then flush. And flush says, okay, save all the changes that happened so far. And then what happens is that my user object has an identifier. Okay, let's grab it and paste it in my code. So, application, controller, index controller. Oh, I already had it here. So I'm just pasting it. Please don't look at the code style because I'm not worrying about that right now. And if I refresh my home page, it explodes. That's nice. Cool. Okay, the demo failed. We can all go home. It was expected. Anyway, no idea whatsoever what is going on, so I'm just going to skip that. I'll just be skipping that. Okay, yes, that should be your face after that piece of code. That's also my face after this live coding demo, which totally failed. Okay, again, what you can do is just persisting an object. You take an object, set some data on it, say to your okay, persist it, and then flush, and then your object has an identifier. You can load objects. You can basically say here, object manager, get me a repository which is, just think of it as a big array of objects. It's a representation of your table. It's not loaded because the ORM doesn't have to load all the tables to just fetch one object, but you can do operations on it. So that's the logical representation of your table. You must think of it as a collection. And you can update it. So the ORM knows how to track your objects. Here I'm loading an object. I'm loading Marvin from database. I'm storing it in variable Marvin. And the nice thing is that Marvin here is an object of type user, because I'm fetching an application entity user. So Marvin is the object, and I'm setting the name. I'm renaming it to Marvin the Paranoid Android, and then I'm flushing. The ORM will internally already know what you changed on your objects and save just the changes. Deleting an object, so you fetch again the object from your repository, and then say object manager, remove the object, and then flush, and that will delete the object. And associations. You stop working with identifiers. Don't use identifiers anymore. You just work like this. So we have an address object here, and this address object looks like the user object that we had before. It has an identifier, it has a country property, that's it, and then getters and setters again. So what happens is that on the other object, on the user object, we can define an address property, and this address property simply references the other object. So we are saying, okay, the address property is a reference to an address. What we can do now is building a new user, setting properties on the user, persisting it. It could also come from the database, we don't know. Building an address object, we can then set the country in this case, persist it, and then we can just say user set address and set the address to the user. You don't have to deal with the identifiers anymore. The ORM already knows how to save this stuff, in what order it has to save everything. When you call flush, all the objects will be saved, all the identifiers will be set, all the operations will be done. You don't have to do that manually anymore. You just define how your objects look like, and then say ORM, please save it. That's it. And now if you just call user get address and get the country for the address, that's it. You already get UK. You're already working with objects. You don't deal with database tables. You don't deal with arrays anymore. And also here, you can define a friends associations. In this case, I'm just telling friends is an association to user, so to itself, to other users. And I'm just saying, okay, initialize this in the constructor and set it to a new array collection. So this is now like an array. Think of it as an array. A collection is just a smarter way of defining an array. That's it. And here we can do the same. So we define a user, set name, persist it. We define another user, set the name, persist it. So we have Arthur and Trillian, and then we define Zaphod, and we save Zaphod. We say persist Zaphod. And then we say Arthur get friends, add Trillian. And Trillian get friends and add Zaphod. Okay? And then we can say flush. That's it. It saves everything in the right order. And so then we can just work with it and say, okay, object manager, get me a user, and then find all the friends for this user. So I say for each of the friends of user, print a name for it. Okay, and in this case, it will just print Trillian, but please note that these associations have a direction, so Trillian is not a friend of Arthur. Okay, so I'll skip on best practices, since as it looks like some people already use the ORM here. So first of all, these are entities. You can do a lot of stuff with them, but keep them simple. Entities are still data. They're now type safe. They have these associations. You now can associate objects and get the ORM to save them in the right order. You don't worry about that anymore. But data is simple. So keep the entities simple. Don't build like objects like a user object that sends emails. That's wrong, okay? Don't send emails from a user object, for example. You don't put any logic in it. You don't say, okay, user, give me the last balance of the last year of history of transactions, of bank transactions. Okay, that's not about, it's not about the user object. That is something you do somewhere else. And the entities know only themselves and the associations. So if you work with clean code, you know this is about the Demeter violations. So try to keep your object aware only of itself and just the associated objects. And again, the common API. Common API, which is basically, as I said, a small set of interfaces that are in the core of the Doctrine project. And if you use those, all that I've shown before will work already also with MongoDB, or with CouchDB, or with OrientDB ODM. Who knows OrientDB? Has anybody worked with it, actually? Okay, that's a bit frustrating, I guess. But it's new stuff, so if you're building social networks, you would probably be using that. But there's a lot of persistence layer out there. And if you use this common API, it all works out of the box. So instead of using the specific ORM entity manager, you use the interface, which is the object manager. That's why I called all the variables object manager. And if you use a repository, don't use the ORM specific one, but use the interface, which is this one, which is in common again. So if you do that, again, it works with all these previous projects. You can move your project from being SQL to MongoDB, from being MongoDB to SQL in moments, really. Collections. I've only shown an array collection before. That Doctrine comes with a very powerful collection API. Collections are just arrays. They're an object-oriented representation of PHP arrays. So for Java people, an array in PHP is basically a hash map. We try to standardize some API with it. So it's like an object-oriented API for this kind of structure. And criteria API. Criteria API, which is a thing that comes with collections. So the problem that is solved is searching. You have this problem, you want to search all users that registered in the last week. You want to search all users which have more than 1,000 euros on their current balance. You want to search all users which didn't receive the last newsletter. That's all use cases that you may have. And it works on virtually any data structure. So you have a collection, you have a hash map, you have a vector, you have a distributed map on various machines. The idea is to abstract that into criteria. This is how it works. What I'm doing here is building a collection. In this collection, I'm saving user 1, user 2, and user 3, which are 3 objects of type user. And then I'm building a new criteria, and in this criteria I'm basically stating criteria where the last login is greater than -1 day, so greater than yesterday. So these are the users. This is basically a criteria that says, give me all the users that have the last login within the last 24 hours. It's a bit strange to read the first times, but if you are used to this kind of stuff, this is very, very powerful. And now I can simply say collection matching criteria. So I built an array, I put some rules in it through this criteria, and I get the filtered collection of users. So this works also with repositories. So if you have an ORM repository, a MongoDB repository, a CouchDB repository, you throw that criteria at it, and what it does internally is it explodes this criteria in a set of rules that get used to search the database. So it works with ORM repositories, and you can search in Elasticsearch, you can search in memory, in the ODM, etc. That's a really nice concept. And they make your code more readable. That's not because you write that way, so with where conditions, but if you use actually object-oriented programming, you can basically extend a criteria object, and in its constructor, pre-configure it. So now you can do repository find new recent users criteria. Isn't that readable? Like table find last login users, table find rich users. That's really readable. That makes your code much, much better. So in this case, I'm saying repository matching new frequent visitors criteria. These are the visitors with a lot of visits on my website. And that's really, really nice if you do domain-driven development. So another thing is injecting the object manager. This is about, again, best practices. You have seen before that I was pulling the object manager from a container. So get service locator and then get something, get a string. That's not a good idea to do. It's not a good idea to do that. So I always suggest injecting stuff. That's dependency injection generally. The idea is that you put dependencies, hard dependencies, what you need in your objects directly in the constructor. That's nothing fancy. That comes from clean code practices. But basically that's it. So somewhere you define a code, which in this case is a factory. This is a Zend Framework 2 factory. I'm just saying that my service, my underscore service, is defined as this closure, which returns an object, and this closure basically fetches the ORM for me, and then builds the my service and returns it with the dependencies injected. So you get away from this trying to pull stuff in your objects from the object itself. It's the Hollywood principle, so don't call us, we will call you. And you also may want to keep the persistent stuff out of your controllers. So if you're writing code for your front end, Don't put the object manager in there. That's something that happens somewhere else back in the code. If you're using a persistence layer like Doctrine, you're probably not building a small blog site. You're probably building a more enterprise level website, so, or generally a project. So maybe you have a service layer, put it there. Don't use the object manager in your controllers directly. And also, as you have seen, the ORM, there's a lot of fancy stuff automagically about knowing who has to be saved when. And lots of people, that's a mistake I see from a lot of people, is that they solve problems that are not about persistence in the persistence layer. So they say, okay, the ORM is smart, let's throw more stuff at it, more. That's magic, don't do that. The ORM is already magic enough. It already knows what to do, so keep it simple. So what I see is people filtering data when it is saved, like trying to remove or building slugs when an object is saved, or trying to escape strings, or trying to remove tags from a string. That's not stuff you should do when saving data. You should do that up front, before the data is even populated with stuff. Validation. The ORM assumes that your objects are valid. So don't throw invalid data at the object manager and then save it and then assume that data will be validated. That's not how it works. Your objects should exist regardless of the ORM. So you have your data structure in memory, or you have it persisted on a database, it should be valid. So don't throw invalid data at your entities, that's wrong. And like saving files when a DB record gets saved, loading files when the DB record gets loaded, that's not what the ORM does. And checking valid stuff when a DB error is triggered, like you throw an exception because someone has put a null in your entity. Don't do that. That's also a mistake. And again, keep your object graph valid. Regardless of the ORM, my user object, as it is in memory, should have a name. That's its valid state. It shouldn't have null as name, for example. So keep your objects valid every time, regardless of the ORM. So again, the ORM works with valid data, so don't use it with invalid data, and generally pass data to the graph only when the data is actually valid. So, okay, I'm passing just a bit on the Doctrine module stuff that is actually interesting for developers. What we have is an object relational graph design tool. I don't know if it works here. It should actually. I'm just throwing out this stuff here. And showing it to you. So this should show again the home page, and what I have here is this small mapping tool, and if I click it, it goes to a page that draws for me an UML graph of my entities. So here it is really simple. We have only the user object, but the idea is that you get to design something like this. You have 4 objects which are related with each other, and on the database it may look completely different, but this is your mental model, this is your object graph, this is the relevant stuff, this is important. The database is not important, this is important, how your object graph looks like. And it's really, really a vital tool when it gets more complex. So this is like 1% of a current project that I work on. And if there wasn't this tool, I wouldn't even understand what is going on. There's so many things going on in this project. And this is basically just some of the objects that are connected with each other. So basically, you install it in Zend framework, and you got this button, and this button makes this magic graph for you, which is really useful when debugging. You get a paginator. Anybody using actually Zend Framework 2 or Zend Framework 1? Zend Framework 1 users. Okay, pagination is a common problem. Pagination is basically about building the page numbers below a search result, or building the number of pages below a list of products you have. And that's a really tricky problem. It may look easy, but this is a tricky problem. So we have various adapters. Now here we have a collection-based adapter, and we have a query-based adapter. So you build a query, pass it to a paginator, and then paginate stuff. And okay, this is all really just stuff that we've thrown in. More stuff. Just everything in this module stuff. And we have validators, so you can just say, okay, this field has to be validated. This value has to exist in my database. In this case, an email address. I must check that it exists in my database, and I can validate it directly, or I can bind it to a form somewhere. This works here. It works in Symfony 2. I mean, this is stuff that you can plug in your project. You don't need to have Zend Framework 2 to use it. And cache bridges. So in Doctrine, we have a cache. What you have here is basically that you can use a Zend Framework 2 cache in a Doctrine project. So if you have like Redis, and you don't have an adapter for Redis or for WinCache, and you want to use WinCache because your system, sysop, decided to use WinCache for no good reason at all, you can basically throw it in and use it in a Doctrine project. And the opposite too. So you have a cache that exists in a Doctrine or Symfony project. You can drag that cache out and put it in a Zend Framework project. So you build a new Doctrine cache and then pass it to this adapter, and it works in a Zend Framework 2 project. Hydrators, that's also a nice concept. The idea is that you move an array to an object, or convert an object to an array. And here what I'm doing is I'm building a hydrator, and I'm saying, okay, this hydrator works with objects of type city. Build a new city. In this case, I'm building a new city, and I am defining an array, and for the name, I'm defining its Bezier. And then I'm saying, hydrator, hydrate this object with this data. What happens is that my hydrator takes this data and pushes it into my object. Regardless of getters, setters, it knows how to push this data in my object. And now if I print get name, I get Bezier. And the opposite is also true. So I can get a data array from it. I can say, hydrator, here's an object, extract data from it, and I get Bezier, an array with name and Beziers in it. So this is really useful if you do JSON APIs, JSON or XML-based APIs. You put an object, throw it at this hydrator, and this hydrator gives you a big array with data. Data and data associated with it. Form elements. I won't even get started with this one, because as you can see, this is quite complex. But basically, you can build drop-downs and checklists and so on, all based on data in some table, and lots of options. Here, just listing a lot of them. And more stuff in general. Everything that I have shown so far works with MongoDB ODM already out of the box. So you can just pick any of the concepts that I've shown and just throw it at MongoDB. It works. And we are going to build also adapters for these three. So CouchDB, ODM, PHP, CR. Who knows PHP, CR? Anybody use that? Java Content Repository? Nope. That's really interesting. If you build CMS projects, you shouldn't do it as I am doing it, but you should use that one, okay? And then the ORMDB ODM, which is a GraphDB, so for social networks. So is there any questions so far?
Is there a version to use in production?
Actually, yes. The versions that are out there are stable. So you mean that it is a development version of the no, we have a stable version. It works with a stable version. I actually have to put an icon on the repository. There's a tool which shows what the latest version is. But you can go on packages. Yeah, I want the URL, packages.org. Packages.org for the people not using Composer. This is basically a big repository for PHP projects, and you should use it. You should definitely use it. So I'm looking for Doctrine or ORM module. There it is. So what you see here is that we have a 070 version, which is stable. This is stable. It is 070 because we're not yet sure about what 1.0 will be, which will be a break. But this is stable. You can use it in a production system with whatever number of users you have. It works. We take care of that. Other questions? Yeah. So you mean a complex query?
Yes.
It's fine. It's fine. So the question is, what about big queries, complex queries? You can build them. The ORM specifically has its own language for that. It's limited. It can't do everything that SQL does, but you can do almost all with it. But then you land in ORM specific land. Then you have to rewrite that piece of code for that, in that case. That may be positive or negative. I mean, some projects don't need to migrate to MongoDB. You don't need to, do you migrate on MongoDB every second week? No, you don't do that. No. You don't do that for fun. So it's fine. It's perfectly fine to write those. If you do reporting, I don't suggest using the ORM, because the ORM introduces some overhead. It makes some things really fast and useful and nice to have and to work with. But for other things, it's not suited. For example, if you have like 1,000 transactions, you want to list 1,000 transactions. That's a thing that works really fast in SQL world, and which is much slower in ORM world. You don't need that in ORMs usually.
Okay, it's for this case. I asked this question.
For reporting?
Yes.
Don't do that in SQL.
Okay.
Do that in SQL. You don't need the ORM, or you don't need the application layer for that. You just work directly with the query and build your giant table of something. That's really, it also changes all the time. Reports change all the time. Yeah, we want this other field here. Yeah, this has also to be normalized with this other function or something like that. It's always crazy, so do that in SQL directly.
Okay.
Thank you. Anything else? Okay. Yeah.
Where do you think is the best place to put the config of Doctrine?
The config of?
Of Doctrine. Do we have to put it in the project or in each module?
Actually, there's two locations. You have this is in the module. So we are talking here about, this is the reusable piece of your applications. This is what you drag from one project to the other. And what I did here is, here I define just the mappings. So I just say connect, here are the entities. Here is where the entities are. That's it. For the passwords and database connections, you use another file which shouldn't be committed to your database. And that's really important. Don't commit any passwords to your version control system, sorry, not to your database. Does that answer your question?
Yeah, it does.
Okay.
But I have another question.
Sure.
Is there a way to use a factory with the repositories?
That is being worked on, but you can just write something like, I'm just picking a random file and putting stuff in it. You can say that foo REPL is like function And you can here just say return you my REPL with service locator get ORM. I mean, the names are made up because this is not ORM. It is entity manager. But basically, this is the concept. You build your specific repository, your implementation. It doesn't need to be a Doctrine repository. It's your repository. It's your logic. It's your language. Okay, in your applications.
When you have, for example, for your entity user, you have many friends. You made a get friends.
Yeah.
So for each user, Doctrine creates the user, but we can't inject our own.
You want to inject the ORM in the user?
Not the ORM, but something else, like Pivetta.
That's a concept which is, this is an anti-pattern. The problem is that you're trying to inject something that is more complex in something which is called a newable. A newable is basically an object you build and it's data. You can use it.
Okay.
So you don't do that. That's generally a thinking mistake. You shouldn't do that.
So where do you put the iterators, for example, to iterate or extract the...
So if you want, like, say, to get the data from a user object, you don't put the iterator in the user and say, user, get me the JSON, for example. You just put somewhere a JSON serializer and you pass users to it. And that one knows how to do it.
Okay.
So you pass the user to something, but you don't pass this something to the user. That's the concept. Is that fine?
Yeah.
Okay. So we're over time by like 4 minutes, so I guess I have to stop. And thank you. And again, if you saw anything wrong, if you find out why the demo didn't work, okay, this is where the slides are. So you can look at the slides, fork them locally, and watch them again. I hope you liked it, and thanks.